All right, so for this problem, we've got to do, it says radio waves travel at the speed of light approximately 186,000 miles per second. How long does it take for a radio signal message to travel from Earth to the moon? So what they're saying is somewhere here on Earth, oops, wrong one. There's a radio tower like this, perfectly drawn radio tower. And then it broadcasts a signal, bloop, 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 bloop. Actually, I'll probably move this. Object, I'll probably move that over here. Actually, you know what I'm going to do? That's still a pretty big radio antenna, by the way. All right, so what we want to do is we want to figure out how long that takes. So it's going to go, essentially, that signal will go from Earth to the moon. How long does it meant to travel to the Earth, to the moon and back? All right, so, and back. So my signal goes all the way to the moon and then bounces back. And the velocity that it goes at, my velocity is equal to 186,000 miles per second. Which is really the speed of light. So that's in miles. So then I got to look at the question itself and see what I have the final answer in. Round in seconds. Yeah, in seconds. How many seconds does it take? So this one, you could convert to meters, but since I'm really just trying to find the time, remember that your distance, or what we would consider to be, our distance is just equal to the rate times the time. In this particular case, our distance, the rate is the velocity times the time. And so we're solving for the time. So we're going to take the velocity, and technically that's not even the right thing because we're not worried about displacement. We're focusing on the total distance. So this would technically be the speed if we wanted to be real formal. And then when you divide both sides by the speed, you would get the total distance divided by the speed, and that gives you the time, which is what they want. How long does it take? So then what we have to do is, in miles, figure out how far away the Earth is from the moon. So according to Google, it's about 238,900 miles. So we're going to write that in our little thing. So this is 238,900 on one way, and then when we come back, it's the same distance. And this is an average because the moon, when it's in orbit, sometimes it's further away from the Earth, sometimes it's closer to the Earth. And also sometimes they measure that from the center of the Earth to the center of the moon. It's hard to say. I have a tolerance in there for the answer. So anyways, so my total distance is 2 times this number. So I'm going to open up a Desmos. that me? That's funny. My phone is listening to me. That's so weird. My phone was listening to me. So we're going to multiply those two together. Right, so I'm going to say 2 times 238. Let me move this out of the way. 238, 900. Boop, boop. And then hit enter. And so I get 477,800. So we're going to plug that in there. So then my total distance, D equals 477,800. And so to find the time, remember we said the time is equal to the total distance divided by the speed or rate. So then that would be 477,800 miles, and it's important that we write the miles in there, divided by 186,000 miles per second. Okay. Now when you divide by this, you're actually multiplying by the reciprocal. So what you're going to end up doing is putting seconds up here and miles down here. The miles will cancel, and your final answer is going to be in seconds. So the only thing I have to do is I have to do 477,800, and then divide that by my 186,000. Oops, I did one too many zeros there. No, I didn't. Yeah, I did the right one. So I get this number, 2.56, right? And so now what I did is on the answers, what I did on the answers is I said, well, it's going to be between 2.5 and 2.6, because if you might have Googled the answers, and sometimes depending on where you find the information, that distance could vary. But any answer between 2.5 and 2.6 would work. And so if you round this to one decimal place, it'd be 2.6. If you rounded it to 2 decimal places, it'd be 2.57. So I'll do, the time is 2.57. And that's it for that problem.